Welcome to the engineering mechanics class. In this section, we'll study wedge frictions. So, before going to the main part of this wedge friction, first we have to know what is actually wedge. So, wedge is a shape that can be of either metal or maybe of wood. It is of both triangular or maybe trapezoidal shape. So, generally, the use of it for lifting heavy loads, for small vertical distances, or for slight adjustment in the position of a body, like tightening fits or keys or for shapes. So here we'll study how the wedge friction comes into play when a body is lifted vertically upwards using this wedge. So in this figure 1, just I want to show that this this is the weight, and normally the weight of the wedge is neglected, and this is the body. D, E, F, G is the body which is placed on this wedge. So that means when we are applying force P in this direction, into the left direction, the weight of this body will be lifted upwards. That means when we push this wedge in the left direction, the body will lift. The movement of this body will be lifting upwards. Okay. Now we have to study what are the reactions and other conditions for both the wedge and the body to be in the equilibrium. First of all, we have to study what are the forces acting in this body. That means in the wedge. Okay. If you resolve the wedge in both horizontal and vertically, so this diagram, it is shown in figure 2. This diagram is the figure 2. So if you see, one normal force is acting due to the surface AC, and also for the weight of this body. Okay. So the normal reaction is this one, and this resultant is due to this weight of this body on this surface AC and the friction surface AC. Similarly, this resultant R2 is the reaction of the normal due to this weight of that body and the friction on this rubbing surface AB. So if we solve the components in both vertical and horizontal directions, we'll find some conditions like equilibrium condition. We'll find some equations. So this R1 is making an angle of phi 1. This angle is a friction angle phi 1. Similarly, R2 is making an angle of phi 2 with this one. So first we will consider the equilibrium condition of this wedge. Then after finding this equilibrium condition, then we will apply the Lami's theorem. So let's see what will be the components in the vertical horizontal direction. This one. So this force P is acting in this direction. So and this one will be acting in this direction. So it will be, our reaction will be your P will be your R1, then sine this component in this direction will be sine component, sine phi 1, then R2 sine phi 2 plus alpha equal to P. Similarly, in the vertical direction, if you resolve it, we will get R1 cos phi 1, this component equal to your R2 sine phi 2, R2, this will be your cos component will be your R2 cos phi 2 plus alpha. Now if we make these forces acting at a point which is shown in the figure, in this figure, figure 3, if you see in the figure 3, then we consider that the reaction R1, R2 and the force P is in acting, suppose at this point. Okay, for these cases the waves is considered to be in equilibrium. So we apply the Lami's theorem. Then applying Lami's theorem, we will get this P divided by sine 180 minus phi 1 minus phi 2 minus alpha, this angle. So this angle is phi 1, this angle, total angle will be phi 2 plus alpha. So if you subtract 180 minus phi 1 minus phi 2 minus alpha, we will get the angle between R1 which is required for the opposite angle of this P. So similarly R1 equal to R1 divided by R1 will be this angle. So 90 degree, sorry, this phi 2 plus alpha, because the angle of this one will be your, this angle will be your phi 2 and this will be your alpha. So this angle will be your R1 divided by sine, this angle is phi 2 plus alpha and this angle is 90 degree. So it will be your R1 divided by sine 90 degree phi 2 plus alpha. Similarly R2 will be your, this angle will be 90 degree plus phi 1. Now we will consider the equilibrium of the body placed on the weight. So how this body can be in equilibrium when it is placed on the weight? What are the forces or reactions we have to consider? First this one, first this one, W, weight of the body acting downward. Then R3 is the reaction due to this normal reaction, because of this plane, because of this DG surface, the normal reaction, and also this is the friction, also due to the frictional surface in this part, due to the friction in this surface duty. So R3 is the reaction due to these forces. Similarly R2 is already we know R2 is this due to this part GF, and normal force N2 is on this GF part of this wedge and between the body. So that angle it is phi 2. So alpha is that angle, the normal angle is making the by the body with this surface, horizontal surface. So this alpha, this is angle is alpha. So now if we resolve the components in a horizontal and vertical direction, then what we will get in this x direction, in horizontal direction, what we will get? R3 sin phi 3, sorry, R3 cos phi 3, then plus, and this one equal to R3 sin phi 3 equal to this part R2 sin phi 2 plus alpha. So this R2 component will acting in this side and R3 component will be acting, that means in opposite direction. So if we balance this one, R3 cos phi 3 equal to R2 sin phi 2 plus alpha. Then if you resolve the components vertically, if you resolve this component vertically, what we will get here? R3 sin phi 3 plus W equal to R2 cos phi 2 plus alpha. So this one. So if you apply the Lami's theorem, then what we will get? W divided by this angle, that means 90 degree plus alpha plus phi 2 plus phi 3. So this one. Similarly R2 divided by this one angle, R2 divided by this angle will be this one, 90 degree minus phi 3. So this one 90 degree minus, similar, then R3 divided by sine 180 minus alpha minus phi 2. So this is the conditions for the equilibrium when a body is placed on a wedge. So first, for this we have first what we have done, we find out the equilibrium condition for the wedge, considering the friction between in this surface and the normal reaction in this surface. Again we consider this body to be equilibrium, then there will be two reactions. R3 we are considering in this part, and one this part, this is R2 we have considered. So likewise we can, if we find out the vertical and horizontal component of this wedge as well as in this body, for the equilibrium using the Lami's theorem we can find out the reaction value. Accordingly we can find out the angle also. So this is all about this wedge friction. So this wedge friction is useful for lifting heavy loads. Here it is shown the triangular, but it can be used for the trapezoidal section also, trapezoidal shape also. Okay, so this is very helpful for lifting body or for small vertical distances.